Good morning. This morning I'm hoping to take the next 20 minutes or so to bring you through our take on a step-by-step approach to implementing performance management in manufacturing plants, particularly using the new technologies and based on the opportunities available to us through what's happening in Industry 4.0 and in IoT. So our particular take on this is particularly performance management. Obviously there's lots of aspects to Industry 4.0 and our interest is in how to manage the plants. My name is Arthur Stone. As Jason said, I'm the CEO of OEE Systems International. Our job is to help customers all over the world, help them to increase their competitiveness, improve their competitive position, increase their production outputs, reduce the cost of their production processes, and effectively deliver and implement competitive solutions within their plants. We work with companies over the last 20 years all over the world, as far west as Seattle, as far east as Shanghai. Many companies you'll know, maybe some of them are your companies and you know us already. And I suppose the common denominator for all these customers is a drive for performance improvement. These customers, some of them are on their early days of journeys for improvement or OPEX or lean or whatever you might choose to call it. They're obviously been faced with the opportunities from Industry 4.0 technologies, and they're trying to get a handle on performance management in their plants, and many of them have moved on over several years to be very advanced and sophisticated in how they handle performance management in the plant. So all this terminology, all these new terms we hear, Industry 4.0 is everywhere, IoT, now we hear IIoT, Industry, Internet of Things, we hear digital transformation, you had artificial intelligence in your intro, we talk about smart factories, factories of the future. It's a little bit overwhelming. I mean, we think we're experts in the game, and we find it overwhelming to try and understand what exactly does it mean, and what are the opportunities and what are the threats of this new revolution. So what's it all about? I've borrowed this from a prediction of a gentleman, a US gentleman, several decades ago now. And he said that the factory of the future will be run by a team of two. Some of you have seen this, a man and his dog. Computers are going to run the plant. The man's job will be to feed the dog, and the dog's job will be there to keep the man from touching the equipment. And that's our vision of factory of the future. And kind of in a funny way, that's maybe some people's view of the factory of the future. My apologies to Mr. Warren Bennett, I've corrupted his quotation, but nonetheless. So we see factories of the future from a performance management point of view as trying to take a step-by-step approach, take small steps to get from maybe very early days of no performance management or very little data collection or very little or no data to where you can utilize all these technologies that are now becoming available to do very smart things. So the first step in our approach to getting a handle on using these technologies is automated data collection. The sort of factory of the future you will maybe think about, or the image that comes to mind when we talk about these terminologies of smart factories or factory of the future, tends to be a homogeneous plant, maybe from one OEM with all the machines the same, all interconnected, all talking to each other, robots at the end of the lines, and everything automated and very few people. And that is one of the visions, and of course we have plants like that, and we have plants like that all over the world. But the reality is that not all factories look like this, and many of your plants probably don't look exactly like that. And something like this may be more representative. And certainly from our perspective, when we work with customers, it tends to be a mismatch of equipment and a mix of equipment. Some of it 20 or 30 years old, some of it brand spanking new with all singing, all dancing sensors and PLCs. And the job, I suppose, for us is to present plant managers with some sort of a vision and some sort of an intelligent understanding of what's happening, regardless of whether the plant is, or whether the equipment is really smart or whether the equipment barely knows it's switched on. Can we get intelligence from that equipment and represent it in a way that's meaningful? So a more immediate and practical challenge for many plant managers is to get one set of meaningful performance metrics across that very disparate set of equipment across the plant. For many of you, and I guess there's lots of manufacturing people here, I'm assuming, given the event we're at, measuring performance today is based on this. Lots and lots of plants throughout the UK are measuring and gathering data manually. So something happens on the line, somebody either writes it onto a piece of paper or puts it into a spreadsheet, they collate the spreadsheet, amend the spreadsheet, adjust it, fix it, whatever they do, tidy up the data, and then they have, at some point in time, usually sometime much later than when the event happened, they have some sort of handle on what happened. That is the most common, even today, with all our talk of smart factories and machines and PLCs, this is by far the most common data capture and data analytics that exists across UK manufacturing. We call this a manual, paper-based data collection, delayed transcription, so it gets transcribed sometime after the event, into a spreadsheet with static charts and reports. So whatever you get from Excel is what you get from Excel. Very little intelligence behind it, very little ability to drill down. Of course, some of you probably have gurus in your plant on Excel that have done wonderful things with macros and drill downs and everything else, and of course, those exist as well. So what we hear when we talk to customers who are capturing data manually, the regular complaints that we hear are things like these, and this may ring true for some of you also here. So we hear things like, we've 2 full-time people collecting and presenting the data. That's what they do, that's their job. We hear, it takes too long to get the information. We hear, the data's wrong, which is amazing, given that you have 2 people full-time doing this and that's their job, the data's still wrong. Not their fault, but the data's wrong. We hear phrases like, I can't use this information to make decisions. I don't trust the data. I won't make an investment based on it, even though we're have all this effort to collect the data. And even with all of this data collection effort, with several people involved in the data chain throughout the process, we still have no visibility of what's really happening on the lines. So this frustration is right throughout manufacturing, that even though we're collecting the data, we're kind of not a lot better off. We're certainly not in a good place in terms of having data that we're happy to make decisions on and happy to make investments on. That's what we hear from manual data collection. So the first step on this journey to using the technologies that are available, the PLCs that are available and the sensors that are available on the line, is to get ourselves automated real-time data collection. I won't go into detail today on the 2 ways we do it, but there's 2 fundamental ways. There's several ways to get data. The 2 fundamental ways to do it are to connect to the PLCs if the equipment is smart enough and can give us enough diagnostics and can tell us what's happening. Unfortunately, as I mentioned earlier, most plants are a mix of equipment, and while there might be some very smart machines, there's typically some machines that are not smart at all. So we have other methods of using real-world signals. So things like if it's a machine that's indexing or a guillotine that's cutting, or we can use other signals throughout the plant to give us the data we want. A simple example is the single most essential piece of information we need to give us this kind of data is a count. So if we can get a count and we know that a machine is supposed to operate at 60 cycles a minute, we expect a pulse every second. So from that single piece of information, I can tell whether a machine is running. It's either generating counts or it isn't. I can tell what speed it's running at. If it's running at 60 strokes and I'm getting a pulse every 60 seconds, it's at full speed. If it's running at 30, I'm running at half speed. And if it's not giving me counts, if it's not giving me pulses, it's stopped. So from one simple signal, we can get some very interesting information. We tend to try and not do it with sensors. In our world, and apologies to the sensor manufacturers in the room, but what we're trying to do is to use existing signals that are on the line. So we're trying to minimally invasive, as the doctors would say, in the manufacturing process, and use what's already there. That's our starting point. You're probably already counting on the line or have a signal that's equivalent to a count that we can perhaps use. And the principle is simply, we don't want human beings to give us timestamps. So, and you probably noticed, our human beings are pretty awful at giving timestamps. When was the last time you saw 11.6 minutes in your downtime sheet? It just doesn't happen, right? You see 5 minutes, 10 minutes, 15 minutes. So we're trying to get away from that. So we need a real world signal or a digital signal that'll tell us what's happening on the line. It can be from the PLC or from some other event, but not from a human being. So that's our first step. The next step with this data, now we've got all this data and we're beginning to get some information, is to use that for real-time operations management. So we've got this data in a spreadsheet. What are we going to do with it? Our first and most basic and most simple step probably is to use that for operations monitoring. So simple things. What's the count? What's the count at the end of the hour? How did the hour go? How did the shift go? And we use the OEE model that many of you will be familiar with to frame that data. So OEE is based on scheduled hours. So we take how many hours you're supposed to run, 8 hours in your shift or 24 hours in your day, whatever it might be. And the OEE model looks at the losses, the things that cause you not to be in production or not to make a production output. The first loss in the model is your downtime loss. So that's easy. That's where the machines are stopped, the wheels aren't turning, the conveyors aren't moving, and we can see that pretty easily. And that gives us the first component of the OEE model. That's our uptime or our availability. That's the line, that's the time the lines are actually running. And out of that time that the lines are running, we have to worry about the times that they're running at 60 cycles a minute, like I talked about, or 50 cycles a minute, or 20 cycles a minute, or when they're running slow. So our second loss in the model is where we're not making the number. We have a machine that's capable of a certain amount, and we're just not hitting that number, and that's a loss to the production capacity. And that gives us the second component of our OEE model called performance. And the third component is where we make a product that we can't ship. We either have to remake it or rework it, which is a second production cycle, or we put it in the bin. But either way, we lose the capacity, the time to make that product. And the mathematics say that the product of the three of those, so availability, multiplied by performance, multiplied by quality, each expressed as a percentage, is your OEE. And that's the traditional OEE model. Many of you are familiar with it. It's been around for decades. It came from originally TPM way back, where it was born to support the TPM programs. There's an easier way to calculate OEE. Again, I'm sure lots of you know the much easier way of calculating OEE. We have to be careful. We're a software company, so we're interested in making this as complicated as possible. But I will tell you a secret, if you promise not to tell anyone outside the room. You can calculate OEE just like this. OEE is the actual output, what you actually made in any period, your shift, your hour, your day, whatever period you want, compared to or divided by what the process is capable of making. So I have a machine that's is capable of 1,000 units every hour, and at the end of the hour I have 600 units. I have 600 divided by 1,000, I have 60% OEE. It's as simple as that. There are reasons that it's more complicated, but that's the way we calculate OEE. Seems simple, but for those of you that work in manufacturing, neither of those numbers are simple.